Hello everyone, here I am Vadir Sagar. Let's get back to the part number 2 of our discussion, chapter number 10, Physics of Light, Reflection and Refraction. Let's start with the second part of its. As we seen in the last slide of our previous discussion is types of mirror through which we will get some reflections phenomena. There is a three type of mirror: plane mirror, convex mirror and concave mirror, as you can see in figure that we already discussed. Let us start to understand what are the mirrors and how it recognize. Convex mirror, first of all, in the figure you can see the reflecting surface is outwardly curved, then the name of mirror is named as convex. As you can see in the first figure, it's curved means reflecting surface should be that you can see the polished inner surface. It means it is a back surface which is coated, and this is the outward surface is the outwardly curved, so it is named as convex. And the concave, this reflecting surface should be inward curved, and it looks like a cave like structure, so that named as concave mirror. Let us understand associate phenomena with the spherical mirror, through which only we will get an idea of the further chapter. Okay, let us start with the first phenomena, first term which is associated with the mirror. Here I am especially taken a concave mirror for our discussion. You can take same these things for the convex also. Here the first term which is called pole, as you can see in mirror, that point P at the middle of the mirror is named as pole, the center of the reflecting surface of this spherical mirror. Here we have one spherical mirror, the center of its named as pole. It represent by P. That is the first term is clear for us. Second and most IMP, center of curvature. Okay, you should know first of all these things. Here the first figure, as you can see, we have huge sphere, huge sphere ball, glass ball, through which we are cut out our mirrors is. Then from where it cut out the mirrors, the center of this sphere is named as center of sphere. Very clear, very easy. Now back here, the center C is the nothing but the center of this sphere from which our mirror is cut. The reflecting surface of the sphere mirror from a part of sphere. This sphere has a center, the center named as center of curvature, represented by capital C. It is very clear for you now. Okay, now that associate term to the center of curvature is one more named as radius of curvature, represented by capital R. It is nothing but the distance between point P, see in figure, distance between radius of curvature is nothing but the distance between point P and C, but we can't define in this way. For understanding point of view, PC is a good distance between P and C. But yes, here P is pole, C is center of curvature. So see the definition of the radius of curvature. The radius of a sphere of a reflecting surface of the mirror from which it is part, it means it is cut out. The radius of its, if you see the whole sphere of this reflecting surface, the radius of it will be the radius of curvature. Simple language I can use, the distance between pole and center of curvature is named as radius of curvature, is represented by capital R. Let us go ahead. Same figure, the one more term which is associated principal axis, which is very important. Please see, imaginary line which pass through the pole center of curvature is named as principal axis. Principal axis is the very important. Why? Because through which we measured our all parameters. In the later chapter you will understand what is principal axis, but it is a imaginary line. That line you can see is belong, or it's contains C point and F point and P point also. The line which pass through it is an imaginary line, that actually it is not existing, only mirror it exists. Other all are the imaginary things. The imaginary line which pass through the C point, P point. Imaginary straight line passing through the pole and center of curvature is named as principal axis. It's very clear. Okay. Okay, go ahead. Principal focus, which is represented by capital F. Let us see. Very important and critical to understand. But let's easy to us. Let's do the easy. Okay, you can see in the figure, please focus in figure. You can see there are the parallel set of rays are comes towards the mirror. Okay. And the mirror is a reflecting surface, so the rays are reflect in a such a way and they are meet on principal axis. That point at where they are meet at the point named as principal focus. Okay, here you can see the first ray, second ray, third, fourth, fifth and five set of parallel rays are fall on mirror and they reflect back towards the opposite directions of incoming. They are focused in some point on principal axis, that point named as principal focus. Definition: a number of rays parallel to the principal axis falling on the concave mirror, they observe to reflect. They are all meet or intersecting at the one point, that point named as principal focus, represented by capital F. Okay, associated one more term with the principal focus is focal length. It's represented by small f. So here student, please take care. Principal focus represented by capital F, focal length is represented by small f. Very easy. Focal length is the nothing but the another distance, as we seen in the radius of curvature, is another distance between P and F. In a simple language I can say the distance between pole and principal focus is named as focal length, but this is a very rude definition, we can't write. The proper definition is the distance between the pole and principal focus of the mirror is named as focal length. Well, one and last term which is associated with this concept is aperture. Aperture, it is means that a distance, a diameter of spherical surface. M, you can see able to see that m to n, the distance is named as aperture. How much bigger reflecting surface you have, that much bigger aperture it has. It means up to which it can reflect the lights, up to which it has capacity to do something. It is particularly mirror it has, so it will be capacity to do reflection, named as aperture. A diameter of a reflecting surface mn is named as aperture. Okay, last and very important for the exam point of view, they are asking define the relationship between r and f. What is r? As we seen, radius of curvature. What is f? Focal length. Okay, in the figure also you can see the distance between P and F is the named as focal length. Distance between P and C is the named as radius of curvature. Is it looks like a double? It means PF and PC. It's just like a double than the PF. Okay, same thing discussed here. Read it. For a spherical mirror of the small aperture, a radius of curvature, this distance PC, radius of curvature is found to be equal to the twice of the focal length. Focal length means PF. If we and put this, R is equal to 2F. The distance is PC is named as R. Distance between P and F is named as F. This F should be, this R should be double than this F. If this PF is 3 centimeter, then PC should be 6 centimeter. Understand dear? Okay. This implies that the principal focus of spherical mirror lies midway. That means at the midpoint of the center of curvature. This is a very clear now. If this PF is 5 centimeter, then PC should be 10. If PC is 12, then PF is 6. Okay. Thank you. Thank you very much.